So hello again everyone. So I'm here again to teach you engineering economy. So our next lesson from our past lesson is lesson number 3. That will be the equivalent compounding. But first of all, what is equivalent compounding? So the definition for equivalent compounding is it is a method or the method used to determine the equivalent interest rate of a certain rate in another method of compounding. To make it simpler, so for example that we have a specific interest rate. Let's say 7% compounded quarterly. Okay? So 7% compounded quarterly. Now what we want to do is therefore for 7% compounded quarterly, you are paying 4 times a year, right? Because that is quarterly. But we don't want to pay 4 times. We only want to pay, let's say, once. Okay, so that will be annually. Okay, so the 7% compounded quarterly, we want to make it compounded annually instead of quarterly. So that is where the equivalent compounding will be used. Okay, so remember, if you are dealing with equivalent compounding, remember that if you want to reflect a interest rate to another method of compounding, remember that their IE, or the effective rate of interest, must be equal. Okay, so the IE1 must be equal to IE2. Okay, so recalling the formula for IE, or the effective rate of interest. Okay, so effective rate of interest must be equal to 1 plus I raised to n minus 1. So I will be your interest rate and n will be your method of compounding. Okay. Okay, so let's try to substitute this into this. So first of all, let's try to find IE1 first. So IE1 will be 1 plus, of course, that will be now I1, or the first interest rate partnered with its method of compounding. Okay, so that will be your IE1. So for your IE2, that will become 1 plus I2 raised to n2 minus 1. Okay, so again, these two must be equal. Therefore, you'll have here 1 plus I1 raised to n1 minus 1. That is your IE1. Okay, this is your IE1. Okay, this must be equal to IE2, which is this one. So you'll have here 1 plus I2 raised to n2 minus 1. So as you can see, we have a common factor, which is -1 and -1. You can also cancel that out. So canceling this out, you will left with 1 plus I1 raised to n1 must be equal to 1 plus I2 raised to n2. Okay, so this can be our formula for equivalent compounding. So later on we have some sample problems. But you can also have here that remember that I, or the interest rate, is equal to what? The nominal rate of interest over the method of compounding, that is J over N. Therefore, I can also say here that I1 is equal to J1 over N1, right? Or, oops, or I2 will be equal to, of course, J2 over N2. Okay? So that's J2 over N2. So substituting this one and this one, the I1 and I2, we will replace I1 and I2 here by J1 over N1 and J2 over N2. You can also have here 1 plus your I1 is J1 over N1. That is J1 over N1 equal to 1 plus J2 over N2. Okay, this is raised to N1 raised to N2. So this can be also our formula. Okay, so I think let's move on to our sample problems. Okay, so we have here number one. Okay, so for number one, we have what is the equivalent rate of 6% compounded quarterly to compounded monthly? So that means that the 6% compounded quarterly, we want it to make compounded monthly. So instead of quarterly, we want to make it monthly. Okay. Therefore, again, don't forget that the magic word for the, if we see the word compounded, therefore, our given is the nominal rate of interest, which is our J. Okay. So let's put the givens first. Mga given. Okay. So we have 6%. So again, we have the word compounded. Therefore, that 6% will be our J. Okay. So let's say that is our J1. It is equal to 6%. Again, we can't use 6%. We have to make it decimal. So this is also equal to 0.06. Next one, it is compounded quarterly. Okay, compounded quarterly. Therefore, our N1 will be what? Quarterly, that is 4. Next, we have compounded monthly. We want to make it monthly. Therefore, our N2 will be monthly, that is 12. Now, we already have all the givens. Now, what is the required? We are required now to find, we are now required to find what? We are now required the equivalent rate of 6%. Therefore, we are required to find J2. Okay, J2. So this must be in percent. Okay. So now for the solution. Okay. Okay. So for the solution, okay. So I'll just write it down. So for the solution, we can use a formula, right? The formula 1 plus no, not the I. We can use instead the J1 over N1, right? From so we have here J1 over N1 raised to N1. Now this will be equal to 1 plus J2 over N2. Don't forget the raised to N2. Okay, so we all have the given, right? So for the givens here, substituting all the givens, J1 will be 0.06 over N1 is 4 raised to N1, which is also 4, and this will be equal to 1 plus, now J2 is what we are looking for, right? So this is will become J2 over N2. Our N2 is 12. Okay, 12 raised to 12. Okay. Okay, so all we have to do is find the value for J2. So finding the value for J2, we can just use algebra. Okay, so this will become now 1 plus, oops, plus 0.06 over 4 raised to 4. What will happen to 12? We have to eliminate this 12 here, right? We can raise both sides by 1 over 12, right? So raising both sides, okay, raise all of this by 1 over 12. Now this will become 4 over 12, right? 4 over 12. This will equal to 1 plus J2 over 12. Now the 12 over 12, that is just 1. Okay? And next, we can transpose 1. Okay, transposing 1. 1 plus 0 0.06 over 4 raised to 4 over 12, that will be 1/3, transpose 1. So that is minus 1 equal to J2 over 12. Okay, so finding J2, all you have to do is just multiply or cross multiply this by 12. Therefore, the value for J2 is equal to 12 times this one. That is 1 plus 0.06 all over 4. This must be raised to 1/3, right? 1/3, and then minus 1. And then, if you will use your calcu here, don't forget to times it by 100, so we can make it percent. The answer here will be 5.9702. 5.9702%. So this would be our answer. Therefore, what the meaning of this is, the 6% compounded quarterly, if we will make it compounded monthly, it will now become 5.9702 compounded monthly. This is monthly. Okay. Okay, so let's go to the next problem. Okay, so for our next number, we have number 2. An equivalent rate of 7% is compounded annually. So if this rate is compounded monthly, what is its equivalent rate? So we have here 7% compounded annually. So instead of compounded annually, we want to make it compounded monthly. Okay, let's just first again write down all the givens. Okay, so we have 7%. Again, we have the word compounded. Therefore, that must be a nominal rate, or what we use symbol for that is J, right? So J1 must be equal to 7%. Again, we cannot use 7%. We have to make it decimal. So that is 0.07. And then compounded annually. So our N1 will be what? Annually. So you are paying only how many times? Once a year. So that's 1. And the next is compounded monthly. So we want to make it compounded monthly. So if monthly, you are paying 12 times a year. Okay. So what is now the required? So now we are required to find again J2. Okay. This must be in percent. Okay. So for the solution, right? Okay. For the solution, I'll just write it down. Again, we can use the formula. The formula again, that is 1 plus J1 over N1 raised to N1 equal to 1 plus J2 over N2 raised to N2. Okay, so let's substitute all these values here. So you'll have here 1 plus your J1 is 0.07 over 1. Okay, N1 is 1. This is raised to 1. Okay, this is equal now to 1 plus J2 is what we are required to find. N2 now is this one. That's 12. 12 raised to 12. Okay, so simplifying this, that is 1 plus 0.07 over 1, all raised to 1. That is just 1.07, right? So 1.07 must be equal to 1 plus J2 over 12 raised to 12. Okay, so we have to eliminate 12 here, right? Therefore, to eliminate that, let's raise all the equation, the whole equation, by 1 over 12. There's another way to do this. You can also use the ln method. Okay. I think we can just use the ln method. Okay, so let's try to use the ln. Ano? Okay, so I'll just delete this one and then delete. So the ln method, so if you will take the ln of both sides, so you have the ln and then ln. The next step is, if you're dealing with the properties of logarithm, this 12 can go down here. Okay, so what you will have here is ln 1.07 equal to 12 ln 1 plus G2 over 12. So this is another way of solving this. You can either use method, the way that I answered number 1, and this method, you'll just get the same answer. Okay, so 12 now will go down here. So you'll have your ln 1.07. Okay, let's put a parenthesis dyan, all over 12. And this is still equal to ln 1 plus j2 over 12. Okay, and next we have to eliminate now ln here. To eliminate ln, raise both sides by e. So raising both sides by e, and you will also have here e. Okay, so whenever e and ln gets side by side, they will always cancel out each other. Okay, so you'll have here e raised to ln 1.07 all over 12 equal to just put some, this will be equal to again e raised to ln will be cancelled out, so you'll just have here 1 plus um, j2 over 12. Okay, so transpose 1, so that will become e raised to 1.07 all over 12 minus 1, and this is equal to j2 over 12, and then multiply the whole equation by 12. This is just cross multiplication. Therefore we can just say that j2 will be equal to 12 times e raised to ln 1.07 all over 12 minus 1 minus 1. Therefore the value for j2, if you will use your calculator, is that's 6.7850. 6.7850%, and that will be your answer. Alright, so let's go to the next problem. Okay, so for number 3, we have a 3% compounded bimonthly has an equivalent rate of 1.508%. So how many times does it pay every year? Okay, so what we are asked here is there is a 3% compounded bi-monthly. Okay, so again, this 3%, since there is a word compounded, that must be a nominal rate of interest. Okay, so let's just put that first in our given. So we have 3%, so that's J1, that is equal to 3% or equal to 0.03. Okay, so that is compounded bi-monthly. If we say bi-monthly, you are paying how many times a year? That is 6 times a year. So we have another given that is has an equivalent rate of 1.508. Okay, so it is says here that the 3% compounded bi-monthly has been reflect to another method of compounding, and when you do that, its equivalent rate will be 1.508%. So how many times does it pay a year? So therefore that 1.508%, it must be an interest rate reflected to what method of compounding. It can be annually, it can be semi-annually, it can be monthly, or something like that. Okay? So therefore we don't see any word compounded into 1.508%, right? Therefore that is not a nominal rate. That is not your J. That is I. Okay? So let's just make it I. Okay, so that's I 1.508%. Now the we are now required to find the what method of compounding is used to 1.508. Therefore, let's just call it N2. Okay. So for the solution, okay. So for the solution, I will just write it here. So for the solution, again the original formula here is 1 plus j1 over n1 raised to n1 equal to 1 plus j2 over n2 raised to n2, right? Now, our first given we already have J1 and N1, right? But the second one we have J2 over N2. Therefore, we already have value for N1 and this N1 and this I1, right? But we don't have any J2 and N2, right? Therefore, what I will do is 1 plus J1 over N1 raised to N1 equal to 1 plus, but we also know that J2 over N2, that is also equal to our interest rate, right? So let's just call this, instead of I, let's just call this I2, okay? So we can say that this is also equal to I2, right? This is also equal to I2 raised to N2, okay? So remember the relationship of interest rate to nominal rate. That's why it became I2. Okay, so let's substitute all the values. So that's 1 plus J1. J1 is 0 0.03. 0 0.03 over and 1 over 6 raised to N1 is 6 equal to 1 plus value for I2. Again, we will not use 1.5, 1.508. We have to make it decimal. So this is 0.01508. That all you have to do is divide 1.508, divide it by 100 raised to N2, and N2 is what we are looking for. Okay. Um. Okay. So I think here we can use the LN method. We cannot use the raising both sides by 1 over N2 because you'll just end up here will just end up having here 6 over N2, which is not good. Okay, so taking the ln of both sides again. So ln of 1 plus 0.03 over 6 raised to 6 equal to ln of 1 plus 0.01508 raised to N2. But again, this N2 can go down here, right? Okay, so putting that N2 here, this will become N2 ln, right? So this N2 will now be erased. Let's just erase this one. Okay. Okay, so all you have to do is put down this ln here. Therefore, the value for N2 will be equal to this one. That's ln raised to 1 plus 0.03 all over 6 raised to 6. And all divided by this one. This ln 1 plus 0.01508. I believe that the answer here is around 1.99. So that is just also 1.99. That's also equivalent to 2. So what method of compounding that you are paying 2? So that is semi-annually. Semi-annually. Okay, so the answer is semi-annually. Okay. Okay, so I think that's it for this video, and I really hope that I was able to help you with your engineering economy again. So stay tuned for lesson number 4, which is the compounding interest. And I'll see you again on our next video. So again, don't forget to subscribe to my YouTube channel for more. So that's it, and I'll see you in the next one. Bye bye.